But before we get started.
Yes.
Before we get started, I have to come up in the front, and I have to say, we need a round of applause to congratulate this man. Not quite our newest Java champion, but close to it. There was another one who got,
just got announced today.
Today,
yeah,
but 2 weeks ago or a week
Roughly
ago.
2 weeks ago, yeah.
And I'm proud to say that he's been involved in Java since.
1998.
Here, move this way, move this
1998.
way.
Yeah.
Oh, no, I'm the one who's moving this way. Anyway, there we go. Here he is. Big shot, yes.
Thank you. Yeah, that was quite the shock. I was actually sitting, doing some writing, and the tweet came in, and when I looked at it, I was, what? So it was quite the surprise, and but yeah. So it's quite an honor to be part of that elite group. You know, it's a lot of longtime Java luminaries that was part of that. So it's an honor to be part of that group. So, but thank you, Barry. Appreciate that. All right, so greetings everybody here in beautiful Madison, New Jersey. It's a gorgeous day outside. And for those of you who are joining remotely, it would be nice to have you here and experience that. So, oh, here come our students. All right. So I understand you guys have finals this week. But yeah, so we have a lot going on tonight. So let me get through the introductory slides that we usually do. So, okay, so our agenda is a little bit different. So we do our usual, thank you to our sponsors, talk about quickly what's new. And I'm going to introduce Curtis Johnson from JRebel, although I'm not sure if he's here, but some of the folks from Perforce are here with us. They're going to do a demo of their JRebel product, which has been around for quite a number of years, actually. And then after that, I'll introduce Tim Spann, who's the presenter for tonight's meeting. All right, so first and foremost, JFrog is our platinum sponsor. We DevOps company. We appreciate their support. This is the third year now that they are our platinum sponsor. Azul is our silver sponsor. And of course, they have their downstream distribution of OpenJDK called Zulu. So you can check them out. Our partner is DevNexus, and for those of you who've been around a while, you're familiar with that name. The annual conference was just held last month in Atlanta, Georgia, and it's becoming quite the popular conference with a number of Java luminaries that speak at that. We have per meeting sponsors. JetBrains, of course, they provide the licenses for IntelliJ IDEA. And also Jakarta EE for Java users groups, they provide Crowdcast hosting for free for any Java user group. So we appreciate their support on that. And then, so what's new? So, well, I failed to mention Java 20 being released at last month's meeting, which was at the end of March. But more notably now, since I follow along with this, there are 11 JDK enhancement proposals, or JEPs, that are targeted or almost targeted. They're proposed to target about 7 of them for JDK 21, which is scheduled to be released in September. The feature set is locked down in June. I think it's June 8th, so less than a month from now. But you see, there's 11 of them already, and I'm not going to go through them, of course. But you can check these all out. What I want to point out is that some of these, like record patterns, pattern masking for switch, they've gone through their incubating or their preview features. Now these are going to be the final ones in JDK 21. The same thing for virtual threads. So this will be a rich feature set. I think JDK 20 only had 7, which was the one from March. So because I think because this is a long-term support release, as they're putting out a lot more features. So. All right, so with that, I want to hand it over to the folks at Perforce. I knew Curtis would be here, but I don't see him here on the Zoom call. So I'll let them take over, and then I'll come back after they're done.
Okay.
Hello, how's everyone doing?
Doing well, doing well. I can hear you all right. So
Excellent.
Curtis, I was just going to give a little bit of background on JRebel, and then I'll introduce you. So JRebel is a lightweight JVM plugin. It eliminates the downtime in local development by instantly reflecting all Java code changes and removing the need to do full build and redeploys of the application server in order to see code changes reflected. So that is a high-level overview of JRebel. Curtis Johnson is our product manager. So he will be able to kind of dive in a little bit on the tool and show you guys a brief demo and answer any questions that you have.
I don't know.
Awesome. Thank you, Haley. So hi, everyone. As she said, my name is Curtis. I am the product manager here for the JRebel product. We'll be talking a little bit about JRebel here today. I'll be going through just a basic understanding of what JRebel is, how it works, and what it's going to be able to do for you and your teams as you're developing and writing code in Java. Now, I know we have a whole bunch of different types of people here on this call from all different types of projects and scenarios. Well, you can rest assured that JRebel will likely work in really anything that you're working at. And the key around what our product is here to do, and really what the focus of what Java or what we're here to help try to solve is productivity. Developer productivity is focused around how are you able to make the most out of the limited amount of time you've got to actually do all of the work you need to do, be able to have in order to be effective at your job. And JRebel is going to help expedite that process and ensure that you're able to experience your development lifecycle in the most effective and free ways possible. So the interesting thing about this product and what it's really focused on is that developer productivity. And in order to do that, what we do is we make it so that you can see changes made in your code on the fly. So let's talk a little bit about your applications. So in general, the way your application works is that it provides you with the ability to read classes within a configuration of your application server. Specifically, it's being used within what's known as a deployment directory. Changes are made. You usually have to redeploy your application into that directory, and then the changes are shown in the environment. This is how the JVM functions at its core. And we were thinking that we could come up with a better way of attacking that in a way that will provide you, a developer, the ability to see those changes without actually having to do any kind of a restart. So yes, as I said, JRebel is going to fast track your development cycle, eliminating the time that's spent waiting for the restart of your application server. So typically, as you know, when you're writing your code, you might do some level of testing of that code, and then building your application, you have to then wait to build and then deploy your application. What JRebel is going to do is it's going to completely eliminate those two steps of building and deploying, allowing you to make changes to your code and immediately see those changes and test out those changes. JRebel is a specifically development-centric tool that is really meant for developers. As I said previously, we're all about developer efficiency and developer productivity, providing you with the most productive life cycle as you're developing and running your code. The largest pain when it comes to this deploy process is usually your application server, but often it also can become your build process as well. But this is a little bit of a breakdown of that, the time savings based off of different application servers. I know we have a whole number of different types of people. Some may be using Tomcat or WebSphere, WebLogic, Glassfish, SAP Commerce. You can have all kinds of different types of Java-based environments. And wherever you are using, Jarable does work. The only real criteria for Jarable to work is that it is working within a Java JVM based language. And in order for you to be able to get the savings. I regularly am looking at our customers and talking to people that are using the product, and we find that we save about, on average, 1 work month every single year in redeploys and restarts that typically you would be experiencing if you weren't using Jarable. One of the things I love about what Jarable does is it really does make it so that you're able to develop and write code a little bit more agile and less having to make a number of different updates and changes and then wait to see if all of those changes worked properly and then validate and test, because it takes so long for you to restart the server. Or even if it only takes a couple minutes to restart, it can add up quite quickly. And that pain of doing it adds up just as quickly. We do work in a number of different IDEs. We actually support Eclipse, IntelliJ, NetBeans, MyEclipse. We just added VS Code just recently as a new IDE that we do support as well. We also support a number of different application servers. Pretty much any application server that's out there, we have support for build tools and frameworks as well. We're widely used, as you could see, and this list is even larger. If you were to see all of the product and all of the scenarios that we do work with, we do have a large amount of different products that we are actual environments that we work with and support. So with that, I'm just going to jump into showing a little bit of this, because who doesn't like to see a little bit of what this actually is doing? And so I actually have my IntelliJ environment up here and running. We are going to open it up. Oh, nice, excellent. So as you can see, I have my environment up and running here. A very basic Spring Pet Clinic application. I'm just going to go to this form, go ahead and submit the form. You can see we've got a couple requirements that are popping up here. There's not a requirement here for the address field for some reason, but there are for the other fields. So what I'm just going to do real quick here, I'm just going to put my name in here into this one field. The reason I'm doing this is to show you that my server isn't getting restarted as I make these modifications, and I'm actually maintaining the state of my application. So let's update this address field so that it has a requirement that pops up here. I'm going to go over to my address field, and I'm just going to simply add this not empty annotation, which will add Jarable in there and simply save this change. Now, inside of IntelliJ is compiling this change so that when I return here to the browser and submit the form again, my change is immediately displayed. And you could see that change. Now the field is displaying that modification. If we return back to the browser, you can see Jarable went to work. It reloaded the class that we modified, as well as its the hibernate proxy that's associated to that class. And reloads that and allows for the changes that occur to the Spring configuration within this class and displays it, obviously, as you saw right there in your running application. You could also see, as I said, Curtis is still being shown, which shows you that we are still maintaining the state of the environment. So this is a major plus when it comes to comparing this to something like Spring Reload or anything like that, where you might be able to, it'll automatically restart your application server after you make modifications. Jarable never stops the application server. the great thing, I literally could keep my application up and running for days on end and never have to worry about ever needing to restart my application server as I'm making code changes and working through the actual code base. And so JRebel really is a pretty awesome tool in its functionality and what it's actually able to do. So let's talk a little bit about what it's actually doing. So JRebel at its core is doing two main aspects within your application. One is that it is looking at the class loaders within your classes, and it's actually modifying the way that those class loaders are where they're actually reading. So typically your class loaders read the files within your deployment directory. What JRebel does is it changes that to look at the where your IDE is compiling those changes. So using IDEs are important, not critical, but they are pretty useful in making JRebel work most efficiently. As you can see, we add a file into your project called the rebel.xml. This is done all automated. As you can see, you have like a little JRebel panel here, and it'll just give you the ability to turn it on, turn it off, and it'll create this file for you. And in here, it will basically tell JRebel where your IDE is compiling changes to. And so in IntelliJ, I actually have, when I hit save, I changed the remapping of this recompile button here so that it will also compile and save any updates that I make in my code, in my files that I'm working on. So when I save the file, it'll also compile it, making it so that JRebel can then reflect that into your application. You can see the class path pointing to this location, so that as JRebel sees those changes made, it'll then upload and reload that change in your environment and make it so that you are still working within that same state of the application and keep on writing and keep on working through your code as you go. JRebel does not require an IDE, though we highly recommend it. We do have plugins, as I said previously, we have plugins in each of the major marketplaces, ranging from Eclipse, IntelliJ, NetBeans, VS Code. And obviously you can see here IntelliJ, this is the IntelliJ plugin that we're looking at right now. And so there's also a file, or JRebel is added into your server as well, which basically provides it with its ability to make these changes as well. And the cool thing is it's actually class loaders that are being used and monitoring these changes in your application code and making it so that you can see it. And you could be able to use something like this to really speed up your development lifecycle. I have talked to many developers who have told me firsthand how using JRebel really time that they needed to be able to actually write better code, be more efficient in their code writing experience. Most people, or it's often told to me that, you hear about our product and you're like, I don't believe it's true. Then you try it for yourself and you're like, wow, it really is, makes a big difference in my ability to write and develop code. And so it's an amazing tool that really provides a lot of real life use case for a number of different customers throughout the Java community. With that, I am going to go ahead and stop and open it up for any questions that we may or may not have. Please ask any questions you might have. I see that we can type it into the chat window so we don't have the microphone issue again. That makes sense. And we can answer anybody's questions. A couple of more popular questions that I can answer as we're waiting for anybody's questions to come in. JRebel is not a production-based product, at least at this point. I'm actually looking into and discussing it with some people on like the use case around something for this in production. But at this phase, the way JRebel works is really geared for the development environment. And with it working in development, it'll provide you with the ability to see these changes, but only as you're developing and writing that code. But then you would not use shareable. Main reason we don't provide it for a production environment is because we don't really have the mechanisms or the safeguards to really deal with errors that may occur and so on that might impact your. Oh, good question. So yes, JRebel does work with other JVM languages. So Scala, Groovy, I'm blanking on any other, Clojure. We do work with all of those different JVM languages as well, providing you with the ability to see changes in those environments as well. And the great thing is it works, it's just the same because JRebel is a JVM plugin at its core. It just has to be added into the startup script for the application server. And then once you've done that, you get JRebel up and running. It's just a simple agent path argument that you add into the server startup. Another question coming in. It's a longer one. While we are waiting, oh yeah, so JRebel does work in debug mode. So if you are working in a debug mode and you're making a modification to a class file and you've got a breakpoint there, JRebel will work with those breakpoints. The only key around this is that you do need to be using one of the IDEs in order for that to work. I assume that you are, but we work directly within the actual IDE debuggers in order to ensure that those changes are getting reflected properly and that we're able to recognize the different breakpoints that are occurring so that you're able to see those updates as well. So yeah, JRebel would not be a very great tool if it didn't work in debug option with debug as well, as debugging is obviously regular life. So for any developers experience. So yeah, we absolutely work in the debugging scenario and we'll work with breakpoints and changes in those breakpoints as well. We do as well support remote scenarios. So what that means, and this kind of goes into the debugging as well, is that if you are working on an application that's deployed to a separate machine than where you're actually developing your code, some similar options would be something like Docker, for example. You would be able to see changes made on that Docker machine on the fly without actually having to restart the server as well. And what this basically is doing, JRebel actually is updating the classes from your local machine and uploading them or moving them to the remote machine. And then JRebel is monitoring where those files are being put and makes it so that those changes can get instantaneously reflected into the environment that you're deploying it off into. And so that is typically a really good scenario where you see JRebel being mostly used in the ability to be able to actually monitor those changes that you're making, especially in stuff like Docker, SAP Commerce, Cloud, Pivot Pivotal Cloud Found, or not Pivotal, I guess not anymore, but Cloud Foundry, and any cloud offerings that are out there as well. Cool. No other questions. Awesome. Well, then thank you guys so much. Sorry about the little technical difficulties we had, but I appreciate everyone jumping in here and being able to talk to us for a little while here today. I'm going to hand it over to Haley now. Haley?
Thank you, Curtis. I apologize for the baby in the background. Yes, thank you guys so much for having us here today. If anybody is interested in, trying out the tool in real time, we have a great 14-day trial that I would be happy to get you set up with. I'm going to put my email here in the chat. And I would love to connect with anybody who would be interested again in trying this out offline here. But if you have any, licensing, pricing questions for me, please feel free to reach out. Okay, thank you so much. I'm going to pass this back over to you, Mike.
Of course, you're more than welcome to stay for Tim Spann's presentation, which I'm going to introduce right now, and we'll get
Mike.
going. Yeah.
Can you say again what you just said?
Oh, why is
The whole
that?
thing.
Oh, the whole thing?
I finally got the audio going.
Oh, okay. So, did we miss Scott's, fair question about how many Java champions it takes to run this meeting? So, all right. So anyway, yeah. So I'll just repeat myself real quick. So,
It must be insane.
so Blessed and Haley, Curtis, thanks for your awesome demo of JRebel. I mentioned last week there was somebody named David when the company was Zero Turnaround, and it's actually David Booth. So who's gone on to other things, of course. But anyway, yeah, JRebel's been around for a good number of years now. So at least 10, if not more. And of course, you folks are more than welcome to stay and listen to Tim's presentation on streams. So with that, I'm going to introduce Tim. He's a principal developer advocate in data in motion for Cloudera. He works with Apache NiFi, Apache Pulsar, Apache Kafka, Apache Flink, Flink SQL, Apache Pinot, Trino, Apache Iceberg, DeltaLake, Apache Spark, Big Data, IoT, Cloud, AI, and deep learning, machine learning. So I see a pattern here, Apache. So yeah, so those of you who know the Apache Software Foundation, they host a number of different open source projects for the Java community and other programming languages as well. So, but Tim has over 10 years experience with IoT, big data, distributed computing, messaging, streaming technologies, and Java programming. He was previously a developer advocate at Stream Native, principal data flow field engineer at Cloudera, a senior solutions engineer at Hortonworks, Senior Solutions Architect at Aris Data, a Senior Field Engineer at Pivotal, and a Team Leader at HPE. He blogs for DZone, which I believe is a competitor to InfoQ.
Give me a spot.
So we're always looking for editors. So let's see. So let's see, where he is the big data zone leader and runs a popular meetup in Princeton and New York City on big data, cloud, IoT, deep learning, streaming, NiFi, the blockchain, and Spark. Tim is a frequent speaker at conferences such as ApacheCon, Developer Week, Pulsar Summit, and many more. He holds a Bachelor of Science and a Master of Science in Computer Science. And on a personal note, I first met Tim 2 months ago over at the IT Professional Conference at the College of New Jersey. So, and he wore an awesome jacket, which he's not wearing tonight, but it was, for those of you old enough to remember the game Pac-Man, it was a Pac-Man jacket. And of course I loved it. So, but anyway, without further ado, Tim, please come on up and look forward to your presentation.
Next time I can give you a smaller list of stuff. And when we do the meetup in Princeton, I will bring I have a Pac-Man projector, so you can play Pac-Man on a wall.
That's awesome.
Yeah. Okay, hopefully everything continues working.
We got it all worked out.
We have it streaming, we got it recorded, all those fun things.
It's being projected to all over the world.
It's the Batman symbol is up, it's on the. That's right.
Let's see. Okay, well, I'll try to get through some of the boring stuff since we had the 25-minute intro there. Get through stuff. I have, for anyone interested, for the next couple of days, we're having a competition developing NiFi, if you've ever heard of it, up until midnight on Friday. Best flow is getting $2,000. So pretty easy to try. I run a meetup in Princeton, sometimes in New York, sometimes in Philly, usually hybrid like this. We maybe do a joint meetup. We'll see about that. I have a free environment for people interested in learning about streaming and not have to worry about how do I configure a bunch of different projects, because that's a pain. So there's a Docker. I know Docker probably should switch to Rancher, but for now, a Docker image that's got a couple different streaming projects together, and all you gotta do is one command runs them all. So you could do a combination of different streaming technologies on one laptop, as long as you have some RAM. Works pretty nicely, and I have that running on my machine here. So I show you part of the demo if things haven't crashed in the hour that I've been doing stuff with pizza. So what is streaming? This could be an entire college course on where that divide is. For most in the business world, it's usually between these two, and that's generally where we stick. I was doing a talk in San Francisco, and I had a guy who's running some very interesting LLM stuff, and he is far below that on some specialized hardware. But most people aren't doing this, because this is, financial people with lots of fun things. Most of the world lives over here in batch, where, I'm happy to get it every couple of minutes, an hour. That's still pretty good. But for modern applications, everything in the last 3 or 4 years, people have been making this switch over to real time, or being able to do things OLTP, whether it's Pinot or Doris or something else, in this area where you could do real-time queries, well below a second is an important part. And I think for the theoretical part to think about it is not having a timer being the cause of the data to happen. Like in batch and micro batch, you're waiting for a time cycle to tell you, okay, next second, next half a second, go, go, go. When we get beyond the batch, it's as soon as something appears, like you sent a message on a phone, a sensor comes in, someone takes a picture, you don't wait for a time. It's when, as soon as that gets into a network and gets to wherever you're going to be doing things, that's when you want to activate it. That's when you want to have code running. I don't want to wait for the second to happen. And as he mentioned, Apache Software Foundation does a lot of open source. Why that is important is when you have projects of this size that require working with petabytes of data, it's very hard for one company, small group of individuals to be able to build a project that can be sustainable without doing that in the open source. I mean, there's very few that have been successful in the last couple of years. So things like NiFi out of the NSA, Flink out of a research group in Germany, Iceberg out of a couple of the big internet properties out in California, Kafka out of LinkedIn. All of these projects started in the open source because that's the only way to grow something that's going to be sustainable when you have to do these kind of fast workloads. And everyone here, hopefully people are Java developers. I'm going to show you it's very easy to also be a data engineer. You know, you don't have to pick one. You just can do both. The first thing that comes up is Spark. Spark is mostly in the micro batch world. I don't do too much with Spark anymore as people have moved on. It is still a good tool for batch, still good for doing things like ETL where I want to grab some files and move them, but we tend to move faster. And some of the technology doing that under the covers is somewhere that can quickly accept that data and accept that data in an ACID format. So, you know, Iceberg's only a couple of years old, but people like the ones you see in these symbols are already running petabytes worth of data through it. So we'll see some interesting stuff happen in there as well. An important project that if you do any kind of streaming, you're going to see is Kafka. And it is not, it took the name from the writer. So I wore my shirt to the Writers Museum and no one knew what I was doing, but I thought it was cool. So what's unique about Kafka, and there's a similar project called Pulsar, is what it lets you do, especially once you get out of one organization, you tend to come up to the point where not everyone is using the same language. Now that Java has 700 versions, not using the same version of Java, I've got 20, 17, and 11, and 8 running in various things. I hope 8 will be gone soon. But to be able to communicate from a Go program to a Python, I just had a text from my data scientist. He's like, we have to do some LLM for the next event. We got to get that done. I'm like, well, you're doing Python. You have fun with that. We'll communicate over a channel that doesn't matter what language you're using. That's why we use Kafka. He'll push, you know, the LLM messages into Kafka, and we'll share a topic, and I'll have something on the other end. Could be a Java app, could be something like Flink, NiFi, any of these other streaming tools. And that keeps us decoupled. That keeps us, I don't care what version of Python he's using. I don't care when he's active, where in the world he is. Is he in the cloud? Is he running off a hardware device? Doesn't matter to me. He gets the data in there, and asynchronously I can work on it. And what's nice, not just me, anyone who wants to subscribe to the data can all get that simultaneously. So if we need to do different things with it, we don't have to wait in one batch line for that data to come in. We each subscribe, we get those events as they happen. As soon as a new message comes in, we all get it at the same time at any scale. And that scale is petabytes for a lot of people, and which is pretty nice. Millions of messages a second, pretty easy, scales out linearly. It is a nice thing to have. These are most common use cases in the real world. Things like every time you move your cursor around on a web page, that sends back messages real time. So, you know, you're hovering on the corner of Facebook, that message is instantly sent to Kafka, and that's distributed to multiple applications doing things with that. The same thing, the backend logs that come out of those servers also get sent event at a time into things like Kafka, monitoring, management. And then at the bottom is when we start writing our apps going, well, all this data is coming in real time. Why would you wait for some random amount of time before you started your program running? It seems kind of silly. So that's what we do with stream processing. A common application use case for Kafka is to act as that buffer. So when I disconnect between physical zones, different networking areas, different parts of the world, this is a real client I have in Texas, and they have a few thousand trucks. And on those trucks, on the bottom of them are real-time devices that have sensors, that have a 5G network, and they randomly talk depending on what's going on. They have GPS, and they have a little agent on them. They send their messages to Kafka that's running on regional availability zones in AWS. In the middle, I've got NiFi applications that put things together, filter them, transform them, and do them without code. NiFi is written in Java and can be extended with Java, but for basic use cases, no code. Obviously, when you say no code, except for that 20% of those use cases that are really hard, which is good because no one wants to be the person writing the code that is copy, one character to another. Field 1 maps to field 2. Let me handwrite Java code for that. No, the days of that are over. I'll show you how you don't have to do that. And then usually gets distributed into other topics. And then things like Flink will let me join live streams of data. And that's really the power here to join any scale, any number of streams together on a corresponding attribute, and do that with plain old SQL like you see in any relational database. Pretty nice. So Flink is kind of the current, most interesting part of streaming to me, is because this is where you actually start building the apps. Before, I'm cleaning up data, digesting it, enriching it, moving it along. But at the end of the day, you want to be able to do something valuable. And that's usually some kind of analytics. This is where we start doing the streaming analytics, where we've got the real-time streams and we could just do it in raw Java or raw Scala, but it's more powerful to do this in SQL, where I could join together these things, use unions, I could do outer joins, all that type of SQL, and do that continuously. What this means is the query is updated every time a new event comes into the topic. I could set up windows of time. This is often used for things like fraud analytics for credit cards. So when those events come into the credit card charges, that's instantly in the Flink SQL, happens right away, and it makes those determinations. Does this look fraudulent? If so, insert a message into a Kafka topic that will trigger a thing to either block the credit card, have a text message sent to you, or some other outcome. So this is why we want to do things like event-driven programming, why we want to be triggered when things happen, and not wait for an hour for some batch job to run and someone run a SQL report and then maybe get an email. I need to know that someone's using a fraudulent card now, so I can stop it, maybe, arrest them while they're holding the card. So that's why you want to do this. And this is used at some of the largest credit card processors in the world and other people at that scale, because there's not many places where you can run any level amount of analytics on any amount of data without having a problem. Now, to make this a little easier, there's a couple of different tools that sit on top of Flink SQL, so you don't have to write SQL at the command line and then hand compile it and push it out there, which you can, and some people do, but there's a couple of tools to make it a little easier. I'll show you a demo of that and then show you some other code behind the scenes and show you what you could do with the pure open source. But having a tool that makes it a little easier is helpful. What's nice is this tool will convert that SQL, run it, and then create a materialized view. So that'll be a REST endpoint that you can pull into something like a Jupyter notebook. So I can hand that off to the data scientist so they can have a window of the latest things. Usually we do like a SQL query that has some aggregates, and I'll give them a continuous REST feed. So every time they refresh, like once a second, which is usually okay for data scientists, they can grab that data for their machine learning or deep learning analytics. And this is not an black screen, hard to read, but the idea is a bunch of fields from different things joined, outer joined, and we do this over a period of time. So when things happen, we keep it, this is our window is 1 second. So all the events that happen in that 1 second, I'm gonna select them back. What's cool is once I have this query working, I throw an insert on the top, and now I could send it somewhere real time as those events get added. So the query just keeps running as events come in. If it meets the criteria, it'll update those aggregates if it's aggregates. And then if there's an insert, it'll automatically go into whatever that inserted downstream sync is, which could be a topic. It could be some kind of real-time table, something like Pinot or Kudu, something that can accept that kind of scale. So pretty easy. What's nice too is, well, that was special. There was something we really wanted to be clicked in. Wow. Okay. So we can pull in data from those more static data stores. To me, a static data store is something you only update every few seconds or maybe once a minute. Maybe it gets an aggregate, because usually once I'm writing to disk, I don't want to write to disk every 100,000 times a millisecond, the cost and the slowness. So usually what I do is I'll batch it together in like a couple of seconds or a minute and then write that for things that don't need that sub-second updates. And then I could use that as lookup data or aggregate data for streams. Something that's important and supported by Apache Atlas, again, infinite number of open source projects. This lets me do data governance. It's important to be able to stream, but without having data governance, who controls the data, who touched my data, what's the, logistics behind that, what's the lineage of my data. This comes up in auditing. How do you prove what we did at that streaming scale is accurate is kind of important, and having something that tracks the lineage, puts up a lineage audit messages, or can block things from happening is important when you're at this scale, and have that separate from the code. We don't want to have to put anything in the code that just isn't code. I want any parameters, I want auditing, I want lineage, I want data quality. I want that separate from the code and from the data. These things have to live separately for them not to, when someone changes the code or updates a version, I don't want my data not to be valid anymore. So this is just an example. We'll go through this. This is my cat. He is very cute. Okay. So I'm going through some of these extra slides later. You could look at these later. I want to get to the demos quickly.
Tim, before you move on, I have a question. NiFi, I haven't heard of that. Can you just give me a brief description?
Yes. I don't want to go too deep because I'm going to show it to you. I think it's easier to show you than to tell you. But Apache NiFi is a project that's about 11 years old. It is completely runs in the JVM. It'll run as small as a few megabytes, and it'll run on your laptop. It is a Java app. It is finally in JDK 17. It'll be in 20 and a little bit. 17 is really nice. So this was a project of the NSA. They needed a way to track live things. We'll just call them things. That's nicer. And to be able to do that at any scale and have it be done by people who are not computer scientists was important, especially 10 years ago. So NiFi is a completely WYSIWYG application that uses the concept of flow-based programming, which is when you get it, you get it. When you don't get it, it's weird. The more you're programming, it sometimes can be weird to just be able to just go in any direction by just connecting things, but I'll show you. So behind the scenes, every box on the screen is a Java app that runs in a controlled Java area, and it's all managed under NiFi, which is a classic clustered distributed application. So, you know, most people will run with at least 3. It can run in standard bare metal, VMs, Docker containers, Kubernetes pods, whatever makes sense for your thing. And it just lets you work with flows of data. So data comes in and you just stream it in between different boxes that do some processing. And the processing could be like run an Apache Tika job, call out to a shell script, call a JVM-based scripting language like Jython or JRuby or Groovy and do some coding on it. Or call your own custom Java app that you drop that jar into the cluster and do some kind of coding. Like I have one that accepts images. When images come in, I run TensorFlow object recognition on it, pull that data out, make that metadata, and have that go along with the data. I'll show it to you in the real thing, but what's nice is it works with binary data, works with tabular data, doesn't really matter, not really good for video, it's more for smaller. Is there a question?
Yeah,
Would it be fair to say to compare NiFi to, say, something like LabVIEW from National Instruments?
I'm not sure I'm fully aware of that
Okay,
tool.
well, so this was something that we used in the lab.
Applications for, I think, very similar to what you were describing with NiFi, except there were C++ modules instead of Java.
Which is,
So,
there
yeah.
is a C++ version of NiFi for small devices. It is a reinterpretation of all the APIs, a subset, because there's already 400 plus components for NiFi that have been written. But it's generally the thought of we work at the file level. Now the file can be as small as 1 byte, but we work, you know, this is basically an extension of the Linux paradigm. Everything is a file, goes to a pipe. And so we're at that level. We're not at where you might be at the, you know, down at the electricity. We work with, you know, ASCII data or binary data, you know, something you might have going through a browser, something going through FTP. This will act as infinite REST endpoint, that sort of thing. I'll show you that. That is my favorite tool. I mean, I got the shirt. And it's harder to get the shirt than you might think. The NSA guys are real tight with those shirts, man. I don't know. I don't know why. There are connectors for everything, including Pulsar, which is another streaming tool that I used to work there, so I helped them put that out there. This is the feature of NiFi that makes it pretty awesome and useful tool for everybody is provenance. So anytime you do anything in NiFi, it builds a metadata record. It can be turned off if you don't like that, and it can be stored in memory, it can be encrypted, you know, every kind of insecurity you might ever want to imagine. But as someone developing code, to be able to see every step as you do things without running a debugger and have that data that can be used as real data and have that turned into a stream of data, or just for when you're writing code, you run one step of the code and then you see what happened, then add another step. And then you go, oh, that was wrong, move it over here. And I mean, literally move it over here and follow the metadata trail. Very helpful for auditing or just for developing code. like I mentioned for the Java people, which hopefully we're all Java people, all the things are implemented in Java. There's some people wanted to write some in Kotlin, and I mean, technically that's possible, but right now it's Java. Everything that it can do, anything you could do in Java, you could call that library from here or wrap it. I've even done deep learning in there, which is a little tough in Java. But this is every kind, you want to connect to a database, you want to connect to any NoSQL store, anything, you can wrap that up and deploy that yourself. Everything in NiFi is extensible. The UI is completely replaceable. You don't need the UI to work. If you like to code in REST and just make REST calls to do all that, instead of having a UI, you could do it. Built-in load balancing, but what's cool about that is when I mention those are separate apps, they do not have to live on the same machine, and it doesn't have to be just one copy of them. I have some people run a 1,000-node cluster. It looks exactly the same as this. You don't know, except this tells me I'm only running on one node, because sometimes you don't want things to be running on 1,000 servers at once. Like if I'm trying to call, say, a relational database, if I have 1,000 nodes call a relational database, I will crash your relational database. So I might just want to read it once, or if I have a file somewhere, I don't want 1,000 people trying to read one file. But here, the load balancer in between them will distribute that data. So maybe I read that file and distribute pieces of it to 1,000 different servers, or 3, whatever you have. Doesn't make a difference when you're coding. You don't have to think about those things until maybe you need to scale up, or you're hitting some kind of wall. Once you're doing once you start getting into the millions of events a second, then you have to start thinking of, well, how do I distribute these loads? I might want to think about that. In between each step is a queue. This queue is configurable size and can be configured with machine learning to automatically resize itself. This is because when I'm developing, I could have an endpoint that doesn't go anywhere. I don't throw the data away. I queue it up, and then when it's ready, I can bring it to that next spot. If things slow down the line, this will automatically put back pressure in. So I'll wait until you're ready to go and just keep it queued up. If we go back far enough in the chain, I'll just stop asking for more data or disable more data coming in. If we can't use the data, we're not going to lose it. And what I mentioned images, but most people use it for data that looks like tables, record-oriented data. And we support a lot of those: Avro, comma-separated values, grokkable log files, IPFix financial data, JSON, Parquet, XML, a lot of different types. And if we don't support it directly, there's ways to convert it into that. Like I can take an Excel spreadsheet and make it readable. I had a friend who wrote an app that reads his email, downloads zip files of Excel sheets, pulls the Excel sheets out, pulls the data out of them, turns it into a table, then automates work. And now he doesn't have to work anymore. Eventually they'll find out and he'll get in trouble, I guess.
Does he still get paid?
He gets paid because they don't know he's not manually doing that. I don't know. If you're a smart enough programmer, you should be able to automate yourself out of a job. Which ChatGPT, we're getting close. You can run SQL on all your data as it comes in. So if you think writing field stuff is too complex, just write some SQL in there. We'll do it for you. And we do have, these are real numbers. And if people want to run it themselves and give it a try, getting, almost 1 million events a second on a single node is not hard. And this, if you can't see that flow because it's very small, low resolution, this is reading from Google storage, unzipping it, doing some commands on it, doing some basic enrichment, then putting it somewhere else. So it's not heavy coding, but it's doing a little bit. For the non-Java people who've been complaining for the last 10 years that you have to use Java to do everything, or Jython or Groovy, we are just putting in for the next version of NiFi the ability to have Python as a first-class executable, which is a real pain from the JVM, but it's working pretty good, and it's helpful for some of the deep learning And this brought up because a couple of us want to do some LLM, large language model use cases, and the Java bindings for that are not really there yet. Python has just got more libraries. There's some links to some stuff. Okay, there's, I mentioned that in the beginning. We have a little contest going on that is using the cloud version of NiFi. This has ways, if you thought NiFi was too hard, that you got drag and drop stuff. So we made it a little easier. With ready flows, you just go to a gallery, pick some basic use case, type in a couple parameters, press deploy, and you're ready to go. And it does common use cases that are, simple. Take something from a message queue, put in a database, that sort of thing. A couple different use cases with cloud stuff. But these are things people had to write by hand before, so nice to make that easier. I'll just go through some of this. I want to get to the demo. I know we're... what's cool with the cloud-based version, because it's on Kubernetes, I could change the version anytime while it's running, shuts down one pod, updates them. It's got some interesting behind the scenes way that it can do DevOps, because everything in NiFi is a REST call. We can start and stop things while things are running and just stop them right before where the data is, have the data sit in the queue, update components, and then have it run after it, and do that on all the nodes independently while we're updating versions. I don't know about updating a JDK version while doing that, but with Kubernetes, we probably can. I don't know if it's the best idea, but another unique feature, NiFi, when you saw it, is running in that designer. Some people don't want to run in a designer. So with a button, you can convert whatever you're running. If it's an idempotent flow, I can turn that into a Lambda function or an Azure function or Google function and deploy that. So they'll be triggered by those cloud events. So you don't have to run a server. Some people like serverless. It doesn't make sense for every use case, but for some of them it does. So it's kind of cool. Here's your Pac-Man. If you would have told me, Tim, bring the Pac-Man, I would have brought the video game we could have played beforehand. I've got a Pac-Man console that projects on the screen. What are you gonna do? I'm gonna go to the demos. Hopefully all my stuff didn't time out while we've been eating pizza or whatever we were doing. I'm making sure I'm logged in here. Let's see. Okay, it's still logged in. Okay, so I'm gonna go to mine. I have a very simple NiFi flow, but I just wanted to show that. This is cloud version of the UI. The UI is not tied to the server. It's all called with REST calls. So there's a couple different competing versions of the UI. There's one that's the pure open source one. You go to NiFi Apache org, you'll get that one. I'll show you that one. This is a competing one because there's that, you can easily write your own. I know a few people have written their own basic ones, so you can build your own tool on top of it if you were so inclined. One nice feature of NiFi is being able to run something once, especially if you're not sure it's going to work. You might only want to run it once. So it's running, and what I did is I called a government RSS feed to get data on the current state of travel advisories in the world. And then what I do is I take that data that comes in as RSS XML feed and convert it to JSON. Because who wants to deal with, I don't want to deal with RSS. And then I split up the data. I build it in a format that I choose. This is as much coding as I usually do. This is JSON path. This is a scripting language to work with JSON. There's also one for XML, and we have a generic one to work with what we call records. So if you get in a record format, you could do it. And then we rebuild it. This is the part that's very helpful, is I can update any field while it's coming in. I could do it as a lookup from a table or something, or from another stream. But here I'm just gonna take other fields and map them on the fly, just for values that I needed. Let's hide that. And then when I'm done, I'm just gonna write it to Kafka. Pretty straightforward, but now it's in the stream. So I took an RSS REST feed, cleaned it up, parsed it, did whatever enrichment I wanted, got it into Kafka topic event at a time. And now those events are streaming somewhere and they can be used as a live stream, or they could be stored somewhere, or 20 people can be doing them. Now this is NiFi running on my laptop. If it didn't time out, it probably timed out. No, yay. As you see, the UI is slightly different. It's still these boxes. And I wrote this one while I was waiting for something to happen. This is calling the MTA. That is the New York. That's a lot of data, I found out. They have a lot of data. They give you updates on all their transit things. If you see here, I've got 80,000 records waiting in there. This is in that queue I was talking about. So I could look at all this data before I process it. So I've had it in there for a day already. I mean, you can leave it in there. This is all the metadata that came from it. So this is all the HTTP variables that came out, all the cookies, headers, unique IDs on them. And I can also get access while it's still in my cache to the actual data. As you can see, not my favorite. It's kind of messy JSON. So I clean it up and get rid of some of that and flatten it out. I'll start this one. Like I said, the nice part of NiFi is I can move the data anywhere I want. If you told me I need to send that to a database, so I'll add a database control, send it there. Now the data is going to go to that database as soon as I put the parameters in, set up a standard JDBC connection pool. Pretty straightforward, but that's all I'd have to do. Okay, it's JSON coming in. I'm going to send it to Oracle. I'm going to do insert. If I want to do some funky conversions of that, I can set up a connection pool. So I'll just create a new connection, blah, blah, blah. Now I send it to a database. And pretty easy to do that. I don't want to set up a database on the fly. That's a pain. I guess I broke something when I did this. Let's see. Now it's back, start. As you see, if it gets too many, what it thinks is too much in the queue, it's gonna stop. So I can change the settings here. By default, it's got a back pressure of 100,000 events, a gig for each one. Obviously, you have everything fill up. You better have enough memory and disk space. It manages in between them. And then we just send it somewhere and I get it into Kafka. Pretty easy to see it. Once it goes into Kafka, I could take a look at it just to see that data coming in. This is actually not in JSON. It's in Avro, but my tool converted that so we could look at it. Looking at binary data isn't very fun. Just to show you how easy it is to move the data in between there. And then with something like, timed out. Flink SQL, I can join. We have one running? Nah, it'd be nice if I had one running. With Flink SQL, I can run jobs live as data is coming in. Sure, that's really easy to see there. This one is doing working on another stream of data. I get real-time flight data as one of the fields. Pretty easy to do. So I just grab that data as it's flying over. That's over my house is where I got my antenna. But as you can see, that picks up most of the state. My antenna is about this long. So I'm impressed with how easy you can pull in ADSB data. But, you know, data is data, lots of different sources. What's that? Yeah. And if you are a nice,
Repeat the question.
yes, he was asking can anyone grab this data? Yes, you buy an antenna off of Amazon. It's or directly from the manufacturer. They've got a nice package deal with some cool case and maybe an extension on it. you run it, they have software. This is the software. You run it on, I run it on a little Raspberry Pi, and it collects the data. What's cool about it, it gives you a local dashboard about it, and it also puts it on their website. If you've ever used FlightAware, it's because hobbyists have all these antennas, plus some commercials and some other places have them. And we all push that data up to them that they are aggregated in a group. And if you send them data, they make you a member and you get to grab other data if you want as well. I mean, for me, just being able to get all the live data here is pretty fun. Like if you look at my query here, I'm looking at the maxes for the altitude, the average speed, the ground speed, for different flight with their identifying tracker. I don't know if I'm sending the data. I might have stopped that flow because I've got too much going on. Because this is all running on a laptop, so, you know, but I have a flow that grabs that data. If I could figure out where that is. But yeah, it's pretty easy. I have an article and a GitHub on that. If you want to know how to do, yeah, here it is, how to do ADSB. Right now, the code is the simplest code. They provide this website you see. Behind this website that's running on your device is a little REST endpoint. So I just call that REST endpoint, grab chunks of data, send it to Kafka, have NiFi parse it down into usable little chunks. But I mean, just having this dashboard is pretty cool. I mean, they just give that to you from their free software. But if you wanted to build further apps with that, you can grab the data from there, parse it up pretty easy, and then write your analytics on it. For me, the most important fields, I've determined them not being a pilot or knowing anything about it. You figure out what they are. They tell you the identification of the plane and the flight, latitude, longitude. This is all data that they have to broadcast for safety of planes. So this goes to the air traffic controllers and anyone else. If you're flying a plane, you would have one of these as well, so you know who's flying near you. Because as you could see, over New Jersey, we're pretty busy. There's a lot of planes going by. So you'd want to know what altitude these flights are and, you know, where they're going. Like this one, you know, sometimes if you see a call sign in there, that'll have telling you that there's something going on. Maybe they're delayed. Maybe they're have to be in a holding pattern. So that kind of information you might want as a pilot. Again, real-time data, there's a lot of sources of it. And combining that with the weather data, with traffic data, and with some travel advisories, I could tell you where not to be when in real time, which is a kind of cool thing. And I could send it to your Slack group.
So am I looking at all the planes that are over this
All
area?
the ones that my plane could reach that don't have their mandatory government ADSB transponder on. And that includes the ones out of our local New Jersey Air Force Base. Very few planes fly with that off because you have to have very high level clearance to fly with that off. If the president was flying by, he would be on there. You would see that come in there. Very few people fly with that off because it's not legal to fly with a plane with that off, unless you're in like a hobbyist plane that doesn't go high enough or a big drone. So that's pretty cool. Unrelated to my talk, but you know, still cool stuff. And like I said, it's like 40 or 50 bucks. You could run it off your regular laptop, but it is running continuously. Like when we used to run those things to, you're like Bitcoin mining, but you're not getting any money out of it. You know, I'm getting data, which to me is valuable. So I don't leave this running 24/7 because if you look at the box, this is going on constantly because it's getting pings back from all these different transponders, and it's never a slow day in this area. I mean, other than, you know, very certain events that have happened, you know, once every 23 years, not too many, that where there's no planes out there, maybe certain weather events. But yeah, so you could grab all this data, do analytics on it while it's happening, and then send it to another data store, do some real-time processing. Like I said, join that with the weather data. I have lat longs, so does NOAA's free weather report. So I can tell you there's a storm here, there's a plane here, maybe they should move across, or if I'm gonna be on that plane, I'm gonna look down at my thing going, it's gonna get bumpy. That kind of stuff. The real-time analytics mixed with other things, pretty easy to join different streams of data or union them. If they don't really join, but they kind of intercept, I could do that with, proximities. Do we have a question?
No, just good stuff here.
Oh, good
Lots of
stuff.
people,
Lots of people. Oh,
lots of people tuning in here.
that's very cool. I've got another one that does air quality. There's a lot of real-time free data out there. And I think I found all of it because I get bored. Like everyone does demos with fake data and you're like, oh, that's nice. You generated some fake banking data. I want live air quality data. I want real-time planes going by. I want logs. I want, someone stuck in a tunnel. I did find out NiFi can produce messages faster than Imager will allow. I have been banned by Imager for uploading 25,000 images a second. They don't like that.
And what's Imager?
Imager's a free web hosting for images, and they have a REST endpoint that lets anyone upload images until some person used a very easy to use software to send them lots of images. What I was doing was taking live pictures, doing deep learning analytics on them. And when you're done with that, you'll get like a part of an image. Now I would take that part of an image, annotate it with the text, and then upload that to Imager so I could show it. And sometimes I forget that NiFi runs really fast. So if you look in some of my code in NiFi, there's ways to slow NiFi down. It has the ability to run on a schedule instead of real time. So I'll put like a cron style scheduler that says, just run once 5 seconds, because otherwise all of a sudden, like you saw on that other screen, we had 87,000 messages sitting there. There are some sources of data that will give you a lot. Like this gives an update every second. If you're in a busy area, I've got 100 planes. If you see the JSON dump coming off there, it's large. Like, am I in the right server? I think this is the right server.
So that's every plane, every second sending a pulse?
It basically sends a message saying, here I am, here I am, here I am, because that's important, where I am in 3D space. So if you're around them, don't go to that same space. Obviously, if you're flying in, you're communicating with towers, but sometimes if you're in a smaller plane or you're, in between smaller airports, you might not be talking to a tower that's anything other than an automated tower, like the smaller airports. There's a interesting one down in South Jersey called Flying W that's got a airplane shaped pool there, really cool airport. But they just have an automated tower. And it's just sending out basically that same kind of thing with a little more information. So you got to be able to track this. People in smaller planes will literally have a laptop with the ADS-B that you can buy as well with that, so they can see who they are and to transpond themselves. They need the transponders part. You on the ground don't need a transponder to send out.
So are there any blind spots in the US where nobody would hear if you sent out?
I wouldn't try to get in your car and put this in your car and then go outside of Area 51, which is an active Air Force base. No, I wouldn't go there. Is there spots where there's nobody? If you look at the map on PyAware, it's pretty, if we go to the main site, like what, it'll show you the lines. If you go to their site for FlightAware, you can look for any place. They track in the entire world Because I mean, it's the official sources plus anyone who's an enthusiast. It's most parts of the world. I mean, because you got a pretty good reach, and some people will hang a 50-foot antenna. Yeah, I'm sure in parts of the desert and over unoccupied areas, they may not be much.
Oh, there's something interesting about the aeroplanes, is there are highways in the sky.
Yeah, you'll see where they're flying. You see that over your house.
Well, planes don't just go across the country. They have highway corridors for aeroplanes. So that's just something interesting about the planes.
There is also a similar, there's similar software for ships at sea, but that isn't as free. And if you're not in the ocean, it really can't run one. So if I was a little closer to the shore, I might be able to run one, but I am in dead middle in the state there. Any other questions? I know we're getting close
I
here.
do have a question, so let me
All
get
right,
that mic.
wait. Let's do this right here.
It's just a quick question.
Then I'll keep it quick.
Thank you. I had a question about the UI that you were running locally. That was the open source UI?
Yes,
Oh, that's that. Okay.
that's it.
I'll just hold it up.
Okay.
So regarding that UI that you were showing, which was running in your local host right now, that's the open source UI.
Yeah.
And
Open source Apache.
and as if you're logged in.
Oh,
Must be some local login, but I'm just wondering, like, is there a way that I could run it in the data center in a company where they actually have their own way of securing apps, and your app that is running in the data center has to actually, support it somehow?
yes. Yes, NiFi has an open security model for authentication and authorization, and it can plug into all the standards, whether it's OAuth or a THENS. There's like 50 of them, and almost all the corporate and government ones it can log into. On the laptop itself, in local mode, it runs an SSL server and does a simple encrypted username and password that you set up when you install it. But yeah, it'll use, if you're using Microsoft security, it could use Microsoft, can use different tokenizers, can use Kerberos.
Yeah.
Obviously, Kerberos, no one likes Kerberos.
The new thing is you want us to multi-factor authentication.
Yeah, it supports
So-
MFA.
There's like a separate place that
Also,
actually does the
You don't need to go into NiFi.
The UI.
You don't need to go into the UI because I can develop, they can give you a NiFi hosted on demand in a secure environment or on your laptop or in a Docker container. You build your flow, it's exported to version control, and then it gets shut down. So that could be pushed on demand to you or done over, like here we have the cloud hosted environment that's in secure and a VPN, all that, 9 layers of security, but it can be spun up. You develop something, store it in a version control or in GitHub, and then have DevOps pull that behind the scenes into an environment where no human has to touch it. And NiFi can automate itself if you want.
I just have more question. It's about that queue concept that you were talking about in the flow. You were talking about a queue concept that you can implement backflow. What actually is behind it? Is it like a real message queue that is encapsulated, or just like?
It's default. It is backed by, there is a area on disk that NiFi takes on each of its nodes that's designed for a local queue. That can be in memory, that can be in RocksDB. When you're running in the Kubernetes version, there's some other places it could be stored, but in general use, it's stored in an encrypted disk area. And that the one thing that can happen with NiFi is you could run out of disk space, like, because you could push too much disk in it, data through it, you could use up a lot of disk if you want to. Like, you could push through petabytes of data in a few days, and if you want to keep all that data around and all that metadata, I can produce a lot of metadata. So these are things you have to keep an eye on. They can be automated to be limited by size or time, or they could be ephemeral. We could have them run in a memory space and then go away. There's a lot of options depending on how you want to run it. You can run stateless NiFi that runs one event at a time and ends like we deployed at Lambda.
With implementing that kind of backflow that is only backed by the disk space, because then you're asking the question like there's data on the disk and it's only on one node.
Yes. If yes and no, depending on how you want to do it.
And you're using something like a IBM MQ, so it's like
could, if you were obsessed about think of this as not as a queue between machines. Think of this as by default a variable in your program. Now, if you want this to leave the space and be distributed for each step as if you were using MQ or Kafka or something else, you could. Most people don't do that because that's a lot of hops. Now, if you had the thing where I need it to be distributed and I need to be never lose something, we could set up these queues to be very small and push and distribute load between servers. And then if you get an ACK back that it isn't acknowledged, it pulls the queue again from Kafka. So you can keep a Kafka queue, keep it so you never lose it until you reach some done point. If you want it as a XA kind of transaction where I have to complete. Again, you might want to use stateless NiFi that will take something, and if it makes it to the end and it fails along the way, it gets rolled back and then the next person tries. If that's your use case, the way it's set up, if the loss factor is near zero, if you have to be 100% exactly once, never repeat a data, never reload it, it can be done with stateless NiFi. But there's only like 5 systems in the world of open data that really do exactly once, never lost data. And they slow things down. You have to have it come from Kafka, go to Kudu or HDFS, or not even S3 supports exactly once with full guarantees. To get that full guarantee, you've got to do a lot. If you need that though, stateless NiFi, Kafka to one of those handful of endpoints, you could do it. If you're talking about, say the top 5 largest manufacturers of anything in the world need to not lose data. They're doing this now. There's manufacturing of people who make some kind of phones who do this for everything built. And it doesn't crash, it doesn't lose it. Now there's ways to architect your flows to make things more durable. If you need top durability, or if you need to confirm things, again, we have that lineage at each step. So if you need to rerun something, you can confirm, you could do checksums on your data. As many checks as you want can be done. Again, this was used by, I don't want to say life and death systems, but yeah, life or death systems on a high scale. So it could be as safe as you need it to be and as lossless. You just have to figure out what your design makes sense for you. Like I said, some things don't need to be, missile system level things. There's lots of ways to rerun something. I put it in a queue, in a Kafka queue or MQ, and then when I'm happy that it's processed to the way I want, then I can remove it from the queue. I mean, that's generally what you do, because the loss levels in NiFi in the last 12 years of production at the top 500 companies in the world are minimal. You know, if someone's lost 1,000 records in 10 years over the 500 largest companies in the world, I haven't seen people complaining. Like I said, but if you are concerned, keep it in a Kafka or an MQ until you get acknowledgement at wherever you think your endpoint is, and then check them. And again, beyond that, we have that auditing at each step that you can check with the lineage. If we get one that's running, let's find it. I think we're doing the MTA here. So if we look at the data provenance, I give you a step of everything that happened on every piece of your data with a unique ID and a timestamp, when it was touched, who touched it, how. So not only do you know you got your data, you can prove who touched it when, and there could be automated encryption at extremely high level securities on each step. So I can put an encryption token on each thing that touched your thing. So you know that it's the exact same data, that no one corrupted it along the way. As deep as you need to go. And it could be really extra deep. But that's not as much fun as loading stuff from plain data. Anybody else? And behind the scenes is Java, so for the Java. So like if you look here, if I wanted to add my own processors, these are mine, and those are written in Java. If you're curious on the source code, it's all in GitHub. So if you want to write your own, you could take your library, wrap it in something that's pretty similar to Spring, deploy it, and get all those advantages of NiFi, being able to drag and drop, lineage, scalability, distributed computing at almost any scale that someone can afford. And then just with whatever code, like I just took Tika code, wrapped it in basically a class that looks like Spring, and then ran it. And now it can be distributed at scale. So make your code easier. You don't have to worry about, how do I write my own lineage? How do I distribute my own programs in an environment that auto restarts, can do exactly once, has 400 sources and sinks? Very easily. You just write what your input is, what your output is, and what you call. Again, wrap any Java library. Going once?
Question?
I mean, it's just straightforward stuff. I'll have all the slides. I'll link them in the group. I already put them up on SlideShare, and I'll post the relevant GitHubs for the different data feeds I showed. And it's pretty easy to import. We export the flow and you can import it back. Pretty straightforward. These are just download as JSON. And then you can just import it and then run it. Set a couple parameters. You got wrap up?
Yeah. Any other questions?
I have a question. I'm fascinated by the collection of data that you have here, but I also realize that in real terms, I don't need to know what planes are flying over my house. I mean, it's fun, it's cool and everything. Are there data that I can collect that'll make a difference in decisions that I make? Things out there that would lend themselves to collection with NiFi?
Yeah, the ones I've seen are people who collect their email. There's people who collect any documents that you might have, like it can go through your Dropbox, your box, your Google Drive, parse your documents, looking for things like, where did I put that stuff? Okay, have NiFi search for it. Have NiFi take every article you ever wrote, grab it, send it to an API to maybe translate it to a different language, put both of those in a database so you can write yourself a live database driven website, or just make them searchable and then to use that to train your own LLM. We do have one guy I'm working with is taking all of the content that has ever been generated by Cloudera in any of our projects, feeding that with NiFi through LLM. So we build our own language model that knows everything about big data. And you could do that yourself. Or, you get spam calls, it could read those, any API. If you don't want to write a REST endpoint for everything, NiFi can act as a universal listener for REST, and you could send any data to it, and it can respond dynamically. So if someone sends in an XML file, it can get it. It could try to see if there's a natural schema for it. And if you have a schema somewhere, automatically convert it, maybe send it create a Word document from it. You could do anything. I mean, it's a nice scripting tool. Like I said, it's the same idea of Unix pipes. There's all these little processes written in Java that can be connected together. They can be croned. They can happen automatically. They can listen. They can actively pull things in. So syslog, you want to tail a log. You want to have something act as an SFTP site. You want to pull off someone's FTP site and keep looking to see if a new file landed. Get that file, parse it apart, see if there's errors in it, change it somewhere, validate it against a database, convert it into a modern data format, and put it in an Iceberg table in the cloud. That's no code, that's 4 steps. And once you figure these kind of things out, and then you're like, well, it doesn't do this library I wrote. Like, you write an awesome library in Java, and you're like, well, you don't have that. Well, then you put that in there. Or just I can shell out to your Java program, or call your REST endpoint, or call your app server. Get those results, put them together, clean it up, put it somewhere else.
I'm anxious. I'm anxious to go home and use this.
Don't chop down a tree with NiFi, but
Yeah, no.
whatever you need.
It sounds great. Oh.
Yeah.
You guys only get one question.
So you mentioned REST endpoints and stuff. I don't remember if I saw it at the beginning. Is there support for GraphQL?
There's a couple of GraphQL processes, but not much. But again, if it's something you're interested in, very easy to pull one in. And it depends what you do, because we could call almost anything. There isn't a good auto querier for most things.
Ability that's been emerging last couple of years now, because REST endpoints could actually either underfetch or overfetch data.
Yeah,
and
those are
GraphQL
WebSockets.
solves that. Oh, okay, yeah. All right.
I think the next thing will be interesting, see if we could run WASM module.
WAS, yeah. Okay. WASM. Yeah.
Yeah, I will never call something an abbreviation. I'm gonna find a way. And I've gotten in trouble with a couple of companies who don't want to be have their abbreviations spelled out. I won't say who they are, but they're in Germany and they don't like that. Don't do that. Don't do that. They will kick you out of the building.
One more question.
Well, here we go. Give that man the mic.
So, is there any way that you can compare NiFi with Apache Camel? They both sound like orchestration, right?
Yeah, there's definitely some overlap. We used to draw this model where there's NiFi, there's SOA, there's Camel, there's ETL tools, and NiFi there's definitely some overlap. But Camel is getting a UI now, which is nice there's a little bit, but Camel works. I'm trying to think of the trigger mechanism as a different style. Like there used to be a Spring project, Spring XD, because I used to work on that at when I was at Pivotal, and that was pretty cool. But it's slightly different. They are more integration tools, and they're sort of designed for, here's a process, do a thing, send it somewhere else. And you kind of stitch together a couple things and they run. NiFi is kind of like the juggling all these different things, doing a little of each one. Like I said, the Swiss Army knife, I start with that first. If I could solve the problem with NiFi, I don't have to write too much code. It makes my job easier. I can write an app that grabs the MTA feed is a very complex JSON feed. I can write an app that grabs that, flattens it, converts it, cleans it up, validates it, and puts it into the cloud. And it took me an hour, and I never saw the data before. I didn't write any code, and it's now scalable and deployable anywhere. That's kind of a nice feature. If I needed to do some complex analytics on it, I do that with another tool. I need to write some complex mathematical code. I probably write some custom Java or Python or Go or Rust or Carbon. But for solving these problems that are, the data changes every day. NiFi can automatically handle that with schemas and inference. So, you send me different data every day, I'm fine. Sometimes the data is an image. Sometimes it's an Excel sheet. Sometimes it's a PDF. Sometimes it's an entire database. I can break it up and do that. I had a client in Camden that downloaded their entire SAP HANA database daily with one line of code, because NiFi can look at an entire data structure and grab all of it. So 250,000 tables, check to see if there was a change and update another database system with, less code than I use to grab that MTA data, because there isn't much to do. And then if it needs to scale more, add another node, it automatically distributes the load. Unless you want it exactly once and idempotent, then there's things you have to think about. Like, you may not want to distribute data if it's going to get out of order. All right, there's lots of thought. Like, before you save it, you might want to have something that keeps it in order, reorder it at the end, or order it real time with Flink SQL that could do orders on, say this 15-minute data, I need to be in order, or maybe endpoints. It gets complex if you want to do complex things, but just getting data and changing it, why write code for that?
Anybody else? Okay. Well, first of all, let's give Tim a hand.
You do your upcoming events?
Oh, you got, yeah. All right, great. So Tim, thank you very much. Go full screen here. Not too. There we go. Awesome. All right. So here's where we do some upcoming events and some other things that are of interest to everybody. Yeah, I keep that up there, that Java Day. I keep that up there as a reminder to myself to try to, let's see if we can get this still to work. So the next big event is QCon New York, which is in mid-June in Brooklyn. And for those of you who know me, I write for InfoQ. So this is the InfoQ worldwide series of conferences. They have them in San Francisco, in Sao Paulo, I think Singapore. So it's all around the world. So New York is back. The last one was in 2019. So I'm looking forward to being there. Our own Neha Sardana is actually a track host on FinTech. So that's awesome. And last I looked, she had at least 4 talks on there. So I have to take a look again. So, but anyway, yeah. So there is a discount code I sent to the email distribution list. Hopefully you got that. I think today is the last day of the early bird pricing. So that was my bad for sending it out so late. But in any event, that's that. JCon Europe is also in a week later in Germany. And the Kansas City Developers Conference, or KCDC, is also a week after QCon in Kansas City. Java 1 is in September, and it's, they've moved from San Francisco to Las Vegas right before the pandemic. And then EclipseCon 2023 is in mid-October in Ludwigsburg, Germany. So I'm sure there's some others that I've missed, but you can check these out for sure and see if you'd like to attend. Oh, and then of course, Jakarta 1 is in early December. And this has been a virtual conference before conferences were virtual. You may recall 2019 was the 19-hour event. We actually had a Java meeting the day and night it was going on. So, but I was asked to be on the program committee again. So of course, I was more than happy to be on there. So we'll probably start putting together talks, and probably I want to say around the summertime, I think. So okay, upcoming meetings for us now. All right, so next month I had this great idea, at least I thought it was a great idea, to have a New York and GSJUG meeting at QCon. And Rustam Memandarov, who I know has already going to be at QCon to have a combined event there after hours. But apparently it's not as easy as I may think. So I've got to look into more of this and then try to see if we can make that work. If not, I'll have to have a plan B. And Tim, I know you offered to have a combined, maybe we can do something at Princeton at some point too. So I think, I'll reach out to you. So, all right, so July, August, July, we have not figured anything out yet. August, we'll probably take a summer break like we did last year. September is already confirmed with Dmitry Choikoy, who's going to talk about Doctor Who. So of course, those of you Doctor Who fans, Doctor Who fans as opposed to Doctor Who. Yes, exactly. And then Matt Rabel has offered us a number of topics. He will be speaking at, and I forget the order it is. It's going to be, I think, Philly, us, then New York on successive nights. So what I'd like to do is ensure that there's 3 different talks for the 3 different groups, so we don't, but so anyway, yeah, so obviously we have a little bit of time to get that squared away. But that October has confirmed with Matt. You may recall Matt was here in person in 2019 and then twice virtual with Josh Long. So. All right, other speakers, we'll have Rustam in there. Mark Heckler, I know, is still trying to get some travel budget to come out and visit with us in New York, as he intended back in January. I reached out to Trisha G at one point, and she'll let me know when she's in the New York area. We can, be great to have her visit with us. And then Neil Ford is somebody I thought about. I know Barry and we used to go to the No Fluff Just Stuff conferences, and Neil was a consistent speaker there. He's always pretty good. So we can try to do that. And of course, I'm sure there'll be others we can try to ask to come visit with us. All right, friends of GSJUG. Tomorrow night, Philly has what they call a Philly Tech Week Super Meetup. So it's a collection of different meetups. So there was a lot of information there. It's going to start at 5:30 tomorrow. The Atlanta Java group will meet on the 16th, and they have Justin Rock talking about breeding 10x developers with developer productivity engineering. And that has to do with Gradle, because Justin works for Gradle. And New York JavaSig is next Thursday. They have Sasha Goldsmith to discuss quantum resistant cryptography using Java. That should be interesting. I know, Barry, you'll be there, I'm sure. So yes, well, you are, you are Mr. Right. You are Mr. Quantum Computing here. So and then the New England Jug / Boston Jug, they have Daniel O, who's actually was named Java champion just today, and he works for Red Hat. And he'll be talking about from Kubernetes native Java. And, oh yeah, so I forgot to update this. I was discussing with Mary Gregleski at the Chicago group. New York's own Gene Boyarsky will be talking about, I forget what the topic is, but anyway, it's June 7th. I think it's June 7th. She may have mentioned the topic, but I forgot what it was. Rules. Okay, and that's it. So, you know, like I said, I'll.
Next month, I'm gonna have a picture of chocolate up there.
Okay. Yes, as those of you who may know me well, I'm a craft beer aficionado. Everywhere we go, my wife and I travel, I always have to try the local stuff. But Barry is our chocolate aficionado here. So, but anyway, so thank you very much. So, thanks again for coming. Stay tuned for details about next month, and we look forward to seeing you then. So, have a good night, folks.